In the second part of section 6.2, we're looking at properties of radicals, which we now know the relationship between radicals and exponents, and so properties should be similar to ones we've already seen. And we've already actually done some of these properties with square roots. So we've already used this property where the root of a product can be split up into two separate roots. The product of those two separate roots. We've already used that to reduce or to simplify square roots. Same thing with a root of a fraction. We've already used that to split up square roots and do some simplifying with those. So this right here, just saying that those same properties work for any power root. So square roots, cube roots, fourth roots, 10th roots, whatever it may be. So we can simplify some of these problems just like we would have with square roots. So here we have a fourth root of 3 times a fourth root of 27. Now neither of those is a perfect fourth power. So if we use the properties and combine these into one root, 3 times 27, so here we're putting them back into one root. 3 times 27 is 81, and the fourth root of 81 is 3. This one's a little different since we don't have an actual number in our root. We just have the variable x. So we have the square root of x to the fifth. Now, x to the fifth is not a perfect square. We could say, now that we've talked about rational exponents, we could say that, well, x times 2.5 times, or x to the 2.5 times x to the 2.5, that does give us x to the fifth, so that's the square root. But that's not really more simplified than having this root here. So we do the same thing that we had done before with square roots, and we look for a perfect square that goes into or multiplies into x to the fifth. And here we're going to look for an exponent that's a multiple of the power of the root we're taking. So we're looking for a square root, so we could really put a 2 there if we wanted. So anything that divides evenly by the root we're taking, any exponent that divides evenly by the root we're taking, is going to come out evenly when we apply that root. So we could split up x to the fifth as x to the fourth times x to the first, and then the square root of x to the fourth is x squared. And another way to think about that is the square root of x to the fourth. We could rewrite that as x to the 4 over 2, and 4 over 2 is just 2. So that perfect square can come out, and we're left with that x still inside of our square root. So this simplifies to x squared square root of x. So making things a little bit more complicated than we saw in the last one, here we have a cube root of 16 y to the sixth. Now 16 is not a perfect cube, but can you think of a perfect cube that divides evenly into 16? That would be 8. 16 is 8 times 2. Oops. 16 is 8 times 2. And then y to the sixth is a perfect cube because 6 is divisible by 3. Okay, that's how we know if something is a perfect cube. If this is divisible by the power of the root we're taking, then that's going to come out evenly. So 6 divided by 3 comes out even, so that will come out cleanly. So the cube root of 8 is 2, so that can come outside of our root. And the cube root of y to the sixth is y squared. So again, just take that 6 and divide it by 3, and that tells you what's going to come out. Or you can think of it as a rational exponent. The cube root of y to the sixth could be rewritten as y to the 6 over 3, which is 2. So those both come out, and all we're left with inside is still just that 2. That was not a perfect cube. So inside we still have this cube root of 2. So 2y squared cube root of 2. Last example here, you'll for sure see one like this on the quiz and on the test, where you have a fraction in there. And again, if the exponent inside of our root is divisible by the power of the root, those come out evenly. Okay, so 10 and 20 are both divisible by 5, so both of these work out nicely. So the fifth root of x to the 10th, well, 10 divided by 5 is 2, so the fifth root of that is x squared. And on the bottom, the fifth root of y to the 20th, so 20 divided by 5 is y to the 4th. And again, consider rewriting these as rational exponents. You'd have x to the 10/5, y to the 20/5, and each of those just reduce to what we have there.